Hello everyone, welcome back to our YouTube channel. The topic to be discussed is capacitance of an isolated sphere. So before we discuss with the capacitance of an isolated sphere, so let us have some idea about electrical capacitance. So basically, electrical capacitance of a conductor is related to its ability to store the electric charge. So when a conductor is given some electric charge, it is raised to some potential. As more and more charge is given, its potential increase accordingly. If charge Q is given to a conductor so that its potential increases by an amount V, then it is found that Q is proportional to V. If we want to remove this proportionality sign, we write Q equal CV. So here C is called the capacitance. So from here we can write C equal Q divided by V. So one should be noted that this capacitance of a conductor depends upon the shape and dimensions of the conductor. Having an idea about this capacitance, now we will discuss capacitance of an isolated sphere. So let us consider an isolated spherical conductor of radius r, having a charge Q. And let us also consider that this conductor situated in vacuum or air. The charge on a spherical conductor may be assumed to be present at its center O. This is the center and this is Q. The potential at any point on the surface of a conductor is given by V equal 1 by 4 pi epsilon naught Q divided by R. We have learned earlier that if we have a charge Q like this, at any point P, which is at a distance R, the potential V equal 1 by 4 pi epsilon naught Q divided by R. So since this is a sphere, the potential at any point on the surface is V equal 1 by 4 pi epsilon naught Q divided by R. This epsilon naught is called the absolute permittivity of free space. So if we make use of this equation, what is the capacitance? C is equal Q divided by V, and this is equivalent to Q divided by 1 by 4 pi epsilon naught, then Q divided by R. So Q will get cancelled. So this capacitance C is equal 4 pi epsilon naught multiplied by R. So this equation shows that 1 farad is a huge capacity. So let us calculate. Suppose if C equal 1 farad. Remember one thing, that the SI unit of this capacitance C, it is farad or F. So if C is equal 1 farad, and we also learned that the value of 1 by 4 pi epsilon naught is approximately equal to 9 into 10 to the power 9. Then the unit is Newton meter square C to the power minus 2. So this is the unit. If we put the value of C and this value of 1 by 4 pi epsilon naught in this equation, so from here R equal C divided by 4 pi epsilon naught. So this is equal to 1 farad. Then 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9, then Newton meter square C to the power minus 2. So since this C, it is in SI unit, and this 1 by 4 pi epsilon naught, it is also in SI unit. So R is equal 9 into 10 to the power 9 meter. So from here we can see that this R, it is very, very large. So 1 farad is a huge capacitance. So practically it is impossible to make a spherical conductor of capacity 1 farad. So this R is 9 into 10 to the power 6 kilometer. So now we will discuss capacitance of a parallel plate capacitor. So first of all, let us consider two parallel plate capacitor. This one is A, this one is B. Say the charge here in a plate A, it is plus Q, and a charge in this plate B, say it is minus Q. So let D be the distance between the two plates, and also V be the potential difference. You have learned earlier that if we have plus and minus, the direction of the electric field, it is in this direction. So that is E. Also, we know that the electric field is equivalent to dV by dr in magnitude. This dV is the difference in potential between these two plates, A and B, and this dr is the distance between the plate. So in this case, so here if we use this figure, we can write E equal V divided by D. Here the distance between the plate is D, and the difference in potential between these two plates A and B, it is V. So therefore we can write E equal V divided by D. So this is the equation 1. Also, we have learned earlier that if we have two plates, one which is plus Q and one which is minus Q, the electric field at any point between the plate is nothing but E equal sigma divided by epsilon naught. where sigma is equal Q divided by A. Here A is the area of the plate. So therefore, if we substitute this value of sigma in this equation, we can write Q divided by epsilon naught A. So this one. We also know that C equal Q by V. So let me mark this one. If we put the value of equation 2 in equation 1, we can write Q by epsilon naught A equal V divided by D. So this Q multiply D divided by epsilon naught A, it is nothing but V. So from here, if we substitute equation 4 in equation 3, we can write C equal Q. Then instead of V, we can write Q multiply D divided by epsilon naught A. So Q and Q will get cancelled. So this C, it is equal to epsilon naught A divided by D. If we fill a dielectric in between these two plates, then the capacitance is equal to K times epsilon naught A divided by D. Here, K is called the dielectric constant. So now, we will solve these numerical problems. So the question says, when 10 to the power 14 electrons are transferred from one conductor to another, a potential difference of 10 volts appears between the conductors. Find the capacitance of two conductors system. So we know that C is equal Q divided by V. Also, this Q, it is equivalent to NE. Here, instead of Q, I'll put NE. But what is N? N is 10 to the power 14. And this E is the electric charge, and its value is equal to 1.6 into 10 to the power minus 10. 1.6 into 10 to the power minus 19 coulomb divide. So here the potential, it is 10 volt. So this is equal how much? So 10, then will get cancelled with this. So this will remain 10 to the power 13. So here 10 to the power 13 multiply 1.6 into 10 to the power minus 19. So this is equal 1.6. So minus 19 and plus 13, this become 10 to the power minus 6. So since this Q we have expressed in SI unit, this one it is in coulomb, and the potential also it is in SI unit. So this C, it is farad. So this C, it is expressed in farad. So this is nothing but equal to 1.6. Then 10 to the power minus 6 farad is nothing but microfarad. So now we will solve this question number 2. The question says, two parallel plate air capacitors have their plate areas 10 cm square and 50 cm square respectively. If they have the same capacitance and the distance between the plates of the first capacitor is 5 mm, what is the distance between the plate of the second capacitor. So, solution. Here it is given that we have two parallel plate capacitor. So one with area 10 centimeter square and another one has an area equal to 50 centimeter square. Also, it is given that the capacitance of these two parallel plates are same. That is, capacitance of one capacitor, it is C1, and the other, it is C2, but they are equal. Say let C1 equal C2. It's also given that the distance between the plate of the first capacitor is 5 mm. D1, it is 5 mm. The question says, calculate the distance between the plates of the second capacitor. So that is D2. So we know that C is equal epsilon naught A divided by D. So therefore, if we put C1, it is epsilon naught A1 divided by D1, and C2, it is epsilon naught A2 divided by D2. So since C1 and C2 are same, so we can write epsilon naught A1 by D1 is equal epsilon naught A2 by D2. So epsilon naught will get cancelled. So we can write D2 is equal A2 by A1, then multiply by D1. So here A2 is 50 centimeter square, divide by A1, it is 10 centimeter square. So here D1 is how much? 5 mm. So the unit of A2 and unit of A1 will get cancelled. So this 50 divided by 10 is simply a number, and here the units of D1, it is mm, so I'll put here mm. So this and this go, so 5 into 5 become 25 mm. If you want to write in terms of centimeter, so this can be written as 2.5 centimeter.